Hello, today we are having a new session in which we are going to discuss the applicative portions of matrices and determinants to various business and economic scenarios. The calculative part of matrices and determinants, the value of the matrices are actually of great help to managerial people who are working in a managerial field trying to calculate cost, revenue and benefits which is going to accrue to a certain financial institution, to a company, to a factory because of various lengthy and cumbersome calculations. On the whole, it is going to be useful to people who are into the applicative mode of various calculative procedures. These things are very cumbersome, realizing that the numbers are varied and the numbers are rigid also. They have to be accumulated. These numbers, these quantities has to be accumulated keeping in mind their characteristics. They has to be written in the format of columns and rows so that they can be actually made, they can be converted into some kind of meaningful actions. So these applicative portions are going to help us to understand the real scenario in which we are going to apply whatever we have studied before about matrices and determinants. These are one of the major methods by which data are tabulated, stored and manipulated. Matrices and determinants has proved already their usefulness in various decision making processes and various analytical tools which can go a long way in helping various economics and sociological matters. There is a particular kind of interrelationship that exists between input, output and matrices. We can use Leontief matrix to calculate how much you should produce to get maximization of profit and minimization of losses. So these are various theories and scenarios in which we will be able to adjust to calculate, analyze and manipulate the figures. We take one example. There are three people, Ram, Sam and Mohan, who purchase biscuits of different brands P, Q and R. Ram purchases 10 packets of P, 7 packets of Q and 3 packets of R. Similarly, Sam purchases all of the three, Mohan purchases all of the three. One packet of the biscuit P costs rupees 4, Q costs rupees 5 and R costs rupees 6. Then using matrix operation, find the amount of money spent by these persons individually. We can calculate these things in a simple manner also, but these are primary applicative parts, so we'll see how matrix can be used. Let Q be the matrix denoting quantity of each brand of biscuit PQR, and let C be the matrix showing the cost of each brand. Because each of these people, Ram, Sam and Mohan, has purchasing all of these three biscuits, we take 3 rows and 3 columns, so Q is a 3 into 3 matrix. The first row denotes Ram, the second row denotes Sam and third row denotes Mohan. The costs are given because whatever you are purchasing, the costs are only going to be one. So P's cost in the first row, Q's cost is in the second row and R's cost is in the third row of the matrix C. So C is only one column matrix. To get the respective amounts being spent by Ram, Mohan and Sam, we multiply Q by C. Obviously we will not be in a position to multiply C with Q, so we will be multiplying Q with C. What we remember is that the number of row or columns in a matrix should be exactly equal to the number of rows in another matrix so that they can be able to be multiplied. So Q has 3 rows and Q has 3 columns and C has 3 rows, so Q can be multiplied with C. So since the columns in the first matrix should be equal to the number of rows of second matrix for multiplication, so we should be calculating QC, not CQ. 10 into 4 plus 7 into 5 plus 3 into 6, that comes to 93. 4 into 4 plus 8 into 5 plus 10 into 6 comes to 116. 4 into 4, 7 into 5, 8 into 6 gives us 99. So the amount spent by Ram, Sam and Mohan is 99, 116 and 99 respectively. 93, 116 and 99 respectively. Now we are coming to the next example. A farmer is producing 3 products A, B and C, requiring 3 materials to be used to produce these units. The requirement per unit of each product is given as ABC 231, 425 and 242. So ABC requires, A requires 2 units of P, 3 units of Q and 1 unit of R. B requires 4 units of P, 2 units of Q and 5 units of R. C requires 2 units of P, 4 units of Q and 2 units of R. Using matrix notations, find the total requirement of each material if the firm produces 100 units of each product. We are going to calculate the first portion in the beginning. So the balance of the question we will see later. We are coming to the applicative portion. The total requirement of each material is 100 units. So we must multiply the 100, 100, 100. This is a row matrix along with the matrix of the units of materials that is required, 2, 3, 1, 4, 2, 5 and 2, 4, 2. So 100 into 2 plus 100 into 3 plus 100 into 1, that is 800, 900 and 800 respectively. So all in all, there is a requirement of 800 units of P, 900 units of Q and 800 units of R for the factory. Now we come back to the question, the second part. The per unit of cost of production, if per unit of cost of material is 5, 10 and 5. So you need to find out what is the per unit cost of material. So we will take matrix M, multiply that by matrix C. Matrix C is given as the cost, 3 costs, 5, 10 and 5. So matrix M multiplied by matrix C. So matrix MC is 2, 3, 1, 4, 2, 5, 2, 4, 2. This is a 3 into 3 matrix multiplied by the column matrix. 2 into 5 plus 3 into 10 plus 1 into 5, that is 45. 4 into 5 plus 2 into 10 plus 5 into 5, that is 65. 2 into 5 plus 4 into 10 plus 2 into 5, that is 60. So total cost per unit would be 45, 65 and 60 respectively for products A, B and C. Now we come to the third part, which is the last part, total cost of production if the firm produces 200 units of the product. We have calculated per unit cost in the second part, 45, 65, 60. This matrix is going to be multiplied by the required number of production, that is P into C. So 200, 200, 200 into 45, 65 and 60. So total cost is 200 into 45 plus 200 into 65 plus 200 into 60, that is 34,000. Hence the total cost of production is coming to be 34,000 for the unit on the whole. Now we are coming to our next set of questions. Example number 3. Mr. X went to the market to purchase 3 kg of sugar, 10 kg of wheat and 1 kg of salt. In a shop nearer to Mr. X's residence, these commodities are priced at 20, 10 and 8. But in the local market, which is a little bit far off, the commodities are priced a little bit reasonably for 15, 8 and 6. If the cost of traveling 25, because you can purchase at home, you can purchase from the market. If you go to the market for to purchase the goods are coming cheaper, but you have to spend some kind of transportation cost. The transportation cost is 25. find the net saving of Mr. X using matrix multiplication method. So we take the number of units required of sugar, wheat and salt. That is the first matrix, that is Q, quantity 3, 10 and 1, 3 kilo of sugar, 10 kilo of wheat and 1 kilo of salt, that is 3, 10, 1. The price matrix, you can see the quantity matrix. The price matrix is given as two different values, the nearer to house and local market. Nearer to house, the prices are dearer, 20, 10 and 18. In the local market, this is 15, 18, 8 and 6. So we multiply both immediately, that is Q into P, 3, 10, 1. I'll tell why this is Q into P and not P into Q, because the number of columns in the first matrix should be equal to number of rows in the second matrix. So if you calculate P into Q, what you will find that number of columns in the first matrix is 2 and number of rows in the second matrix is 1. So you will not be in a position to multiply them. So that is why this is Q into Q. Number of columns is 3 and number of rows are 3 in the second matrix. So you will be able to multiply it. 3 into 20 plus 10 into 10 plus 1 into 8, that is 168, added together. Then 3 into 15 plus 10 into 8 plus 1 into 6, that is 131. So cost of purchasing from the shop is 168 when you are purchasing from a place which is nearer to your house. But if you are going to the local market, you are spending 131 rupees, plus on travel you are spending 25 rupees because you have to travel away from your home. So your total cost including travel is 156. If you purchase from the local shop which is nearer to your home, you are spending 168, but now you are spending 156. So overall there is a saving of 12 rupees. So this means on the whole there is a difference between both the units that can be purchased from two different places. If you purchase from the local market, you take the benefit of the lower cost, so you are saving rupees 12. Now we are coming to a little bit applicative part. Instead of a normal multiplication, we are going to solve some kind of linear equation. So this is a kind of complicated thing. There are a lot of complicated things in matrices and determinants, but going by your university syllabus and university course that is going to be there in the examination, we are not going to do very difficult portions because they are not desired from a management perspective, but still we will be going to do some kind of applicative portions, what you should do so that you will be in a position to understand exactly what happens with a system of linear equations. So here Mr. X has some amount which he invests 10% bonds, bond A, and a part in 15% bond B. This means if he invests some amount in bond A, he gets 10% interest. If he invests some amount in bond B, he gets 15% interest. His total interest income is 4,000. So 10% of A plus 15% of B is 4,000. If he invests 20% more in 10% bond and 10% more in 15% bond, his income will increase by 500. Find his initial investment and new investment using matrix method. Let the initial investment be in the bond X be bond A, which is 10% investment interest bearing, and Y in 15% bond B, which is 15% interest bearing. So the first equation we get is 10% of X plus 15% of Y is 4,000. When you convert that, multiply that numbers by 20, you get 2x plus 3y, which is 80,000. Why multiply by 20? Because you have to convert them into non-decimal values. The first equation, the left hand side of the equation is in decimal places, so you need to remove the decimal places. You can multiply by that by 100 also to remove the decimal places. So 2x plus 3y is 80,000, that is equation number 1. The second equation is 0.12 of x plus 0.165 by y, because it is saying that if you increase the investment by 20%, so if you increase investment by 20%, you will get 20% more in interest. So that is 10% plus 20% of 10%, that is 2%. So overall you get 12% interest, plus 15% plus 10% of 15%, that is equal to 16.5%. So 0.165y is 4,500, because over the initial amount of interest you are going to get 500 interest more. So 0.12x plus 0.165y is equal to 4,500. By multiplying them, by removing the uncertainties, you get 8x plus 11y is 3 lakh. We can write these values in the matrix equation form. We take the coefficients. On the left we have a coefficient matrix, that is 2x 3y 2 3, 8x 11y 8 11, multiplied by the alphabet matrix, that is x into y, is equal to 80,000 and 3 lakh. That is the right side of the equation value. So matrix A multiplied by matrix B is equal to matrix C. It is in a multiplicative form. What we do now is we calculate the A inverse. We have already discussed the A inverse thing. To be able to show that an inverse exists, we must calculate the determinant of A, determinant of the first matrix. The determinant of the first matrix is 2 into 11 minus 8 into 3, that is 22 minus 24. So it is coming to be minus 2. So determinant of A is minus 2, that is non-zero. Only if the determinant is non-singular, then A inverse will exist, said to exist. So solution, we can calculate x is equal to A inverse B. A inverse B is 1 upon determinant A into adjoint A. We calculate adjoint A of the matrix 2 into 11 minus 8 into 3. So because this is a 2 into 2 matrix, we will reverse the values, numbers. So the adjoint matrix comes to 11, 2 and minus 3 and minus 8, because the sign changes for A12 and A21. So 1 by minus 2 into 11 minus 3 minus 8 and 2 multiplied by 80,000 and 3 lakh. 11 into 80,000 plus minus 3 into 30,000, that is 8 lakh 80,000 minus 3 lakh 30,000. So that gives us minus 20,000, and then we have minus 8 into 80 plus 2 into 3 lakh, that is minus 40. So overall we have minus 20,000 and minus 40,000, which is the multiplication. Then we take 1 by minus 2. So both the items will be divided by minus 2, minus 20,000 by minus 2 and minus 40,000 by minus 2. We find, because minus minus will be cancelled, so the resultant value of x is 10,000 and 20,000. So which means the new investment, the old investment x and y, is 10 and 20,000 respectively in bond A and bond B, and the new investment would be 20% more in A and 10% more in B. So 10% plus 20% of 10%, that is 12,000, and 20,000 plus 10% of 10,000, that is 22,000 in bond A and bond B respectively when the new investments are made. Now we come to our next question, next problem. An automobile company has 3 types of steel which it uses for producing 3 types of cars, C1, C2 and C3. The 3 types of steel are given S1, S2 and S3. The steel requirement is given in the following matrix. To produce C1 it uses 2 units of S1. To produce C2 it uses 3 units of S1. I can tell it in another form, that to produce C1 it uses S1 of 2, 1 units of S2 and 3 units of S3. To produce C2 it uses 3 units of S1, 1 unit of S2 and 2 units of S3. To produce C3, car number 3, it uses 4 units of S1, 2 units of S2 and 1 unit of S3. Determine the number of cars of each type which can be produced using 29, 13 and 16 tons of steel respectively. So the maximum amount of steel that is available with the company under the present circumstances is 29, 13 and 16. So it will not be in a position to use more than that number of tons of steel uh, for the company. So you must find out what is the number of cars going to be if it is going to use only 29, 13 and 16 tons of S1, S2 and S3 class of steel. Let's X and Y and Z be denoted as the number of cars that can be produced. So we find that 2x, that is 234, plus 3y plus 4z is 29. 1x plus 1y plus 2z is 13. That comes from our first matrix, that is 2x plus 3y plus 4z is 29. 1x plus 1y plus 2z is equal to 13, and 3x plus 2y plus 1z is equal to 16 tons of. So we have three equations. The above information can be represented using the matrix model, that is, we take the coefficients in the first model, then the X matrix X, Y, Z, then the right hand side we have the coefficients which are given to us as the results 29, 13 and 16. So we have to find, we have already discussed one of the these questions. So I would like you to evaluate these by yourself. I have given you the equation. Please find X is equal to A inverse B. A is given, B is given, so you have to critically determine the value of A inverse. For that to do, you must first of all calculate determinant A. If determinant A is not equal to 0, then the A inverse will exist in our book. So under that circumstances, you must calculate the A inverse first, then go on, A determinant first, and then go on to calculate the minors and cofactors and adjoint, and then A inverse B. The solution is given to you for checking purpose. So my request, my suggestion is that you calculate it yourself and see whether you are able to grasp it or not. We are coming to another question which is a little bit different. We are using Cramer's rule in this. A company produces 3 products every day. 3 products every day. The total production on a certain day is 45 tons. It is found that the production of the third product exceeds the production of the first by 8 tons, while the total combined production of the first and third is twice that of the second product. Determine the production level of each product using Cramer's rule. Total production is 45, so x plus y plus z is 45. 3 units, so x, y and z. So x plus y plus z is 45. It says that the first product plus 8 is equal to z. We can convert that into minus x plus 0y, because there is no y present, plus z is equal to 8. Then it says that the addition of the combined production of the first and third, so x plus z is twice that of the second, so x plus z is equal to 2y. The third unit, the third equation, x plus z is plus 2y, so that makes it fundamentally, if you take the left 2y to the left hand side, it is x minus 2y plus z is equal to 0. We can write these three equations in the following format. Take the coefficient into the first matrix, x, y, z in the second matrix, that is the matrix X. So you take the answer into the other matrix, so 45, 8 and 0. From these matrices which we have converted from the three equations which is given to us, we have to find the determinant of the first matrix. The determinant is coming to be 6. You can either expand it by the first row, or you can also expand it by the first column. The determinant of the matrix A is coming to be 6. Since determinant of the matrix is not equal to 0, so non-singular matrix this is, so there is a unique solution which is existing, so we will be in a position to calculate A inverse of the matrix. But we will not be calculating A inverse. Actually the question is asking us to find the answer by using Cramer's rule. Determine the production level of each product using the Cramer's rule. So Cramer's rule is actually known as the determinant method. It is not the matrix method. In the matrix method we will be using the A inverse thing, but here we are going to calculate value of x is equal to d1 upon D, value of y is d2 upon D, and value of z is d3 upon D. But we have already seen what is the D. D is the determinant of the matrix, the original matrix A. But what is D1? To calculate D1, you must substitute the right hand side values 45, 8 and 0 for the first column of the matrix A. Then find the determinant. Because you have substituted the first column, it is known as D1. D1 is coming to be, by expanding through the first row, D1 is coming to be 66. When you calculate D2, you have to substitute the second column by the right hand side values 45, 8 and 0. So this is known as D2. Again, by expanding by the first row, we get D2's determinant as 90. In the D3, we must substitute the third column by 45, 8 and 0, and the determinant D3 is coming to be 114. Now we are in a position to calculate the value of x, y and z. So after finding out D1, D2 and D3, we will be in a position to find out the value of x, y and z. X is D1 upon D, that is 66 by 6, 11. Y is D2 by D, that is 90 by 6, that is 15. Z is D3 by D, that is 114 by 6, that is 19. So the production of the three types of products are calculated to be: the first product 11 tons, the second product to be 15 tons, and the last product Z to be 19 tons. So Cramer's rule, we calculate three determinants by substituting each of the three columns which is given to us by the right hand side values, the B matrix B values, and we able to calculate x, y, z as we have already discussed. So you must follow these rules to find values by Cramer's rule. Now we are taking another subject for discussion, another question for discussion. A company earns before tax profit of 1 lakh. It is committed to making a donation of 10% of the profit after tax to Red Cross. The central government levies a corporate tax of 50% of profits after deducting donation and local taxes. The company must pay local taxes of 10% of its profits less donation. Compute how much company pays in tax, local taxes and Red Cross. Use again Cramer's rule. So the three equations we have to make from the given question. X is the amount donated to Red Cross, Y is the amount given as corporate tax, Z is the amount which is given as local tax. According to the given information, we have X is equal to 0.10 into 1 lakh minus Y minus Z, 10% of corporate tax and local taxes. That is what you are going to give as a donation to Red Cross. We can convert that into 10x by multiplying both the side by 10. We get 10x plus 10y plus 10z plus y plus z is 1 lakh. Then y is equal to 0.5, 50% of 1 lakh minus x minus z. So that is again x plus 2y plus z is equal to 1 lakh. You have to convert this equation from the left hand side to the right hand side. You can write it and solve it. You will, I'm sure you will be definitely going to get this. The third equation is z is equal to 10% of 1 lakh minus x, the Red Cross value. So when you multiply that by 10, you will find that x plus 0y, because y is not present in this equation, x plus 0y plus 10z is equal to 1 lakh. We convert these three equations which are on the right hand side into three different equations, three different matrices: 10, 1, 1, 1, 2, 1, 1, 0, 1. Multiplied matrix x is 1 lakh, 1 lakh and 1 lakh. Now we have to calculate the value of the original determinant, that is 10, 1, 1, 1, 2, 1 and 1, 0, 1, 1, 0 and 10. By expanding with the first row, we get the value of the determinant which is 180, which is non-singular, which is not equal to 0. So the inverse of the matrix do exist for this question. I have given you the answers. You have to solve by yourself to find out the value of x, y and z. What do you have to do? You have to find D1, D2 and D3 as we have done in the previous question by replacing the first, second and third column respectively by the right hand side values 1 lakh, 1 lakh and 1 lakh in three equations. Another question is here, a firm produces two products X and Y, passing through two machines M and N before completion. M can produce either 10 units of X or 15 units of Y per hour. N can produce 15 units of either product per hour. Find the daily production of X and Y if time available is 12 hours on machine M and 10 hours on machine N, using matrix inversion method, that is the invertible matrix method. So because we have given that X matrix machine M can produce 10 units of X and 15 units of Y, this or this. So we have to take the equation as X by 10 plus Y by 15 is equal to 12. This gives us, by inverse multiplying, this gives us 3x plus 2y is equal to 360. The second machine M, it can either produce 15 units of the first product and 15 units of the second product. Both are similar, so x by 15 plus y by 15 is 12. It has 12 hours in all. By converting them, that becomes x plus y is 150. So we have two equations basically, 3, 2, 1 and 1 multiplied by x and y is 360 and 150. This is 2 into 2 equation, so we will not have to find the cofactors. The cofactor, the value of A12 and A21 will be reversed, that is minus. So A inverse is 1 minus 2 minus 1 and 3. X is equal to A inverse B, which is 1 minus 2 minus 1 and 3 multiplied by 360 and 150. By multiplying them, 1 into 360 plus minus 2 into 150, that is 60, minus 1 into 360 plus 3 into 150, that is 450, so 90. So the value of X is coming to be 60 and 90. So the products which machine M and Y can produce are actually going to be X 60 units and Y 90 units. You have to practice it again. As you go on practicing these questions, you will be able to grasp it quickly, and there will be a lot of practice questions which will be given to you in the form of assignments, so you should be also using those. Now we have come to the end of this session, and we have studied the applicative portions of matrices and determinants, which are useful in simplifying various difficult keywords and procedures. Without them, we will not be in a position to calculate a lot of things very easily. We have to take, of course there are softwares which are available, Excel format, SPSS format, the different format of software which is available to us, but softwares are not going to be handled by everybody in equal measure, so we must know the theoretical portion, how they are used. So matrix and determinants come to our aid in those formats. When it becomes more complicated, we cannot use linear equations. So that is when matrix and determinants are very useful, and hopefully you have understood calculation of inverse and Cramer's rule. We will be continuing with another session next time. Till then, bye bye. Keep on practicing. Thank you very much. Bye bye.